Hello, Math 7 students. This is Open Up Resources Unit 2, Lesson 2, Introducing Proportional Relationships with Tables. This is the second video in a two-part video series. We are going to be finishing this lesson today. To get started, we're going to review what we did in our last video. I need you to complete this table of this proportional relationship. You can see some relationships here among the numbers that are already in the table. Use those relationships to help you complete the empty spaces. Pause the video until you have done that. I made this table intentionally difficult to find any pattern except for the pattern going across the table. I purposefully made it difficult to figure out how to change a 0.5 to a 3 or a 3 to a 2 or even a 2 to a 5. So you had to look for other patterns, specifically how does a 3 change to a 21 or a 2 to a 14. Thank you for the hands. Birdie, you multiply it by 7. It works both parts on the table. 2 times 7 is 14. 3 times 7 is 21. And even here, 0.5 times 7 is 3.5. So we can assume now that we can continue that pattern by multiplying by 7. And 5 times 7 is 35. I should have entered 35 here in the calculator. Most of you left this blank. There was another spot on the table that you needed to fill out. 1 times 7 is 7. Please pay attention to the scroll buttons in your calculator. When it looks like this, when it comes to you, you have to press on the scroll button in order to scroll to the bottom to see everything that you're supposed to do. So please understand that. I know that we're in a technology age where everything's touch screen and you can just kind of scroll down, but this is an old-fashioned thing. It's called a scroll button, and you do need to know how to use it because using the scroll bar doesn't work so nicely on your own calculator screen. Overall, not too bad. I think we're ready to continue the lesson. Let's quickly review the things that we noticed in our lesson in the last video, and that is we looked for patterns and we really focused hard on the patterns that help us go across the table. So even though we know how to change a 2 into a 5, a 2 into a 10 by multiplying by 5, and we would do the same thing here, those strategies didn't help us with our warm-up. So we always want to look for that pattern or that relationship that will take us across the table. 2 times 3 is 6, 3 times 3 is 9, so we were able to use that and go 10 times 3 is 30, and use that same relationship working backwards, that if I'm going forward to multiply by 3, to go backward, I would divide by 3. Or to go backward, I would multiply by 1 over 3 or 1/3. We also can find relationships going forward even if the numbers are getting smaller. So 6 changes to a 3. Yes, we can think of it by dividing by 2, but I always prefer that multiplication relationship. So we reminded ourselves that dividing by 2 is the same as multiplying by 1/2, and we use that multiplying by 1/2 to work across the table. We can also work backwards by dividing by 1/2, or as we wrote here, working backwards by multiplying by 2. Okay, we also had this last problem, which again, while we were able to find some relationships going down the table, we really needed to focus on how we're going forward in the table. And we discovered that even when the numbers are not quite as nice, we can still find them by working backwards. For example, we didn't know off the top of our head how an 8 changed to a 10. And since we didn't know how an 8 changed to a 10 with multiplication, we used division and worked backwards. And we did 10 divided by 8, which we saw right here. We can write that as the fraction 5/4 or the decimal 1 25/100 or 1.25. So we were able to use that and know that going forward, I'm multiplying by 1.25. So 20 times 1.25 is 25. 13 times 1.25 is 16.25. And we can also work backwards then by dividing by 1.25. So we have this last question here that I decided to leave for today. What is the proportional relationship that is represented by this table? There are a couple of ways that we can answer that question. Really, ultimately, what we're looking for is we want you to describe the relationship between one column and the next. So one of the things that we can write here to describe this is we would say the relationship, and we're writing because I'm writing, the relationship between honey and flour is proportional. I also want to start recognizing some new terminology, some new vocabulary that we can use. So the relationship between honey and flour is proportional. As we mentioned before, that means that it's a collection of equivalent ratios. So that's just saying all of these ratios are equal. Another way that we can talk about this, so yes, I do want you to write this one down as well. The amount of honey is proportional to the amount of flour. But I also want to focus on this new relationship that is becoming more and more and more important. So we're going to write one more thing here, and that's this. To go across the table, we multiply by 1.25. This is the main thing from this whole lesson, is recognizing these relationships that help us go across the table. And so, as we work on this next example, which I'm going to set you to work on your own, I'm going to ask that you do this in a certain way. It is a relationship between quarters and dimes. And I know that you guys know the relationship between quarters and dimes. So understanding that relationship monetarily, like that 40 cents is 40 cents is 4 dimes, how many quarters would that be, and stuff like that. It's a great way to check your answer, but I really want to focus on the mathematical relationship. So as you're answering these questions, please start by answering this. How does a 4 change to a 10? And then use that relationship to fill in the rest of those spots on the table, which will then help you answer those questions. So get started with your groups, starting with how does a 4 change to a 10? And then use it to answer the rest of the questions and fill in that table. Pause the video, online learners, until you have completed this, while the in-person students work together in their groups. Pause the video now. Okay, we're back. Students have had a chance to discuss, and online learners have paused long enough that they can also answer these questions. We start with this. How does a 4 change to a 10? Did anybody know just off the top of their head? A few of you maybe. Let's pretend like we don't know. How did I even figure this out? Gabe. Exactly. If we don't know what we're doing when we go forwards, we go backwards. But if we're going to go backwards, we also need to make sure we use the backwards relationship of division too. So I don't know, so that's why I'm going to work backwards. 10 divided by 4 is equal to 5 halves or 2 5/10. So what am I doing when I go forward? We are multiplying by 2.5. Please always double check. I have had students in the past where they get really, really confident, but they made a mistake. So check. Plug it into your calculator. 4 times 2.5. Does it really give you 10? Don't tell me yes until you've plugged it in. 4 times 2.5. Does it really give you 10, McGuire? It officially gave you 10? Okay, let's move on then. What should I be doing here with the 1? Should I be multiplying it by 3? Multiplying it by 2? Multiplying it by 5 halves? Yes, because 5 halves is the same as 2.5. I caught a few of you on that one, didn't I? We can multiply it by 5 halves. We can also multiply it by 2.5 because it's the same number. It's just whatever is going to be easier to type into the calculator. And 1 times 2.5 is, that's easy, 2.5. And 6 is also going to be multiplied by 2.5. Ladies and gentlemen, do you see how I'm not being lazy and I'm writing this on every single row? I want you to do the same as well, because we need to make sure that we're making connections and we're really focused on finding that relationship as we go across the table. And 6 times 2.5, thank you for these hands, is what, Luke? 15. And 14 multiplied by 2.5 is what? Leah. What is it? Is it? Okay, that was too hard for me to do in my head, so I couldn't check her work on my own. Thank you. So, let's answer these questions. How many dimes are equal to the value of 6 quarters? Well, let's see, we have 6 quarters, and that would be 15 dimes. Does that actually work, like looking at the actual amounts? 6 quarters, how much money is that? Caleb? $1.50. And 15 dimes, how much money is that? It is also $1.50. So that's nice when we can look at it one way mathematically and then look at it another way quantitatively and still have it all work out. What is 4 quarters? What is the value of 4 quarters, Aiden? $1. And what is the value of 10 dimes? Also $1. Again, I love that we can check our answers here by looking at this quantitatively and really looking at the value of these amounts. Okay. How many dimes is equal to the value of 14 quarters? So we have 14 quarters, and that would be 35 dimes. And this one's hard for me to do in my head too. 14 quarters, what is the value of that? Do you know that quick? What is it, Kaden S? It is $3.50. Good. And 35 dimes is equal to $3.50 again, right? Okay. Here's another important question. What value belongs next to the 1 in the table? Well, we found that, and that was 2.5. But what does it mean in this context? Good, a few hands. What does it mean in this context? Brighton. I'm sorry? It doesn't mean how much money we have necessarily. I want to focus on the 1. Have we focused on 1 in the past? And how important that 1 is? Kaden M. Kind of. So again, I really want to focus on this. It says the 1 in the table. That means, ladies and gentlemen, what we have here is the unit rate. Have we heard that word before? Have we heard that word a lot before? Yes. Whenever we have the 1 in the table, we have the unit rate. And this is the unit rate for dimes per quarter, which kind of is what Kaden M was saying. If I have 1 quarter, that's the same as having 2.5 dimes. Can we have half of a dime? Kinda. It would be considered a nickel, not half of a dime, right? Could you cut the dime in half? Yeah, and then it's useless. But what we're seeing, though, is that this is the unit rate of dimes per quarter. And I really want to focus on just how important this is. Whenever we have that 1 in a table, isn't it really easy to see what's on the other side? 1 times 2.5 is 2.5. So this is a really important relationship here with the 1. That's why we're taking that time to talk about it and really emphasize it. It's the unit rate, dimes per quarter. Are you ready for more? We're actually going to skip because it's something that if you are interested, you're going to have to look it up online at home. And I'm not going to do that here in class. So if you want to do that, you can, but I am skipping it. Which means that we are ready for our Lesson 2 summary. If the ratios between two corresponding quantities are always equivalent, the relationship between the quantities is called a proportional relationship. This is really important because what we're doing is we're making this connection, as I have mentioned in the past, that when we have a collection of equivalent ratios, so again, ratios that are equivalent, we have a proportional relationship. I'm going to write that again in a different way. A collection of equivalent ratios. I have a lot of students who are in class who are not focused, who are not paying attention, they're not highlighting or writing like they should be. I hope these online learners who are watching the video are doing better. A collection of equivalent ratios is a proportional relationship. Have we dealt with equivalent ratios in the past? A lot. I was at 6th grade and that's what we spent the whole first couple weeks reviewing is equivalent ratios. But now we're sophisticated 7th graders and we don't say equivalent ratios anymore. Instead, we say a proportional relationship. It means the same thing. But when we use the word proportional relationship, we're able to see the relationship in more than just ratios. We can see it in a graph, and we can see it in a table, and we can see it in equations, and we can see it so many different ways, and that's why we go even further, and we stop talking about just the ratios, and we look at all of the other characteristics. So it says this table shows different amounts of milk and chocolate syrup. The ingredients in each row, when mixed together, would make different total amounts of chocolate milk, but each of these mixtures is all going to taste the same. So if you want 1 cup of chocolate milk, you'll use 1 cup of milk and 4 tablespoons of chocolate syrup. And if you want more milk, then you would probably use 2 cups of milk, and then you would also need to use extra syrup. You would need to use 8 tablespoons. So each of these quantities that are mentioned are going to create recipes that will taste the same. Notice that each row in the table shows a ratio of tablespoons to chocolate syrup that is equivalent to 4:1. All that that's saying is we can simplify each of those ratios to 4:1. Let me actually show the work for that. We have 4:1, and that's the same as, I'm going to skip this one for right now, that's the same as 8:2. That's the same as 12:3. It's even the same as 1:1/4. All of these are equivalent ratios. And I'm running out of space, so I'm not going to mark it down, but how does a 4 change to an 8? Gabe? Times by 2, so the 1 is also times by 2 and we get 2. How does the 4 change to a 12 to get all the way over here? How does the 4 change to a 12? Jerem? We times by 3, so the 1 is multiplied by 3 to give me 3. Challenging question now. How does the 4 change to a 1? How does this 4 change to a 1? Kaden M. Oh, good. I like it. We can times it by 1/4. We can also divide by 4 too. But I like that reciprocal relationship. We can times by 1/4. So 1 times 1/4 is 1/4. So we are seeing equivalent ratios. They're just listed in the table now instead of being written out like these ratios here. So these 4 sentences say the same thing but in different ways, and they all talk about that relationship. So again, instead of just saying equivalent ratios, we're talking about the relationship between these quantities. We can say the relationship between the amount of chocolate syrup and the amount of milk is proportional. Thank you for highlighting with me. The relationship between the amount of chocolate syrup and the amount of milk is proportional relationship. I'm going to go back and highlight more. The relationship between blah, blah, blah is proportional. The relationship between blah, 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 blah is a proportional relationship. We could also say the table represents a proportional relationship between, and then list those things. Or we can say the amount of something is proportional to the amount of something else. Again, each of these sentences is saying the same thing just in a different way. Notice each of these sentences is using that word proportion, proportional, or proportional relationship. Other things to notice. We can multiply any value in the chocolate syrup column by 1/4 to get the value in the milk column. Let's take a look at that. Once again, we would ask questions like this. How does the 4 change to a 1? How does the 1 change to a 1/4? How does the 12 change to a 3? And everywhere in that table, we would answer by saying we multiply by 1/4. Could you also see it as dividing by 4? Yes, but we always want to focus on that multiplication. So everywhere on that table, I would go forward, I would go across the table by multiplying by 1/4. So we can multiply any value in the chocolate syrup column by 1/4 to get the value in the milk column. We might also call, and I'm going to switch over to red because that's the color I did the unit rate before. We might call 1/4 a unit rate because 1/4 cups of milk are needed for 1 tablespoon of chocolate syrup. It's just like that question that they asked over here. What does that 1 in that table mean? That 1 in the table tells us the unit rate. And the last one, I'm going to underline this one in orange because throughout the rest of this unit, what you may have already noticed so far this unit is I've always used orange for this specific relationship. Take a look at all of these tables. Going forward, what did I use? Orange. And this one, going forward, what did I use? Orange. And here I used orange, and here I used orange. So I'm going to continue to color code using orange. And that color orange means it is the constant of proportionality. The constant of proportionality, please write this down. It is the number we multiply by to go across the table. The number we multiply by to go forward across the table. We can call it the constant of proportionality. We can also call it the proportional constant. You'll hear it referred to both ways. And a proportional relationship is just equivalent ratios. All right. Something else that I want to really emphasize now so that we can get it in our heads the right way. We wrote down that the constant of proportionality is the number we multiply by, which means as we look at this example up above, you might recognize that 8 divided by 4 is 2, but 4 is not the constant of proportionality. We need to ask, how do we multiply to go across? And that's multiply by 1/4. I want you to make that connection. Even if you see a division relationship, change it into multiplication. And I've said that lots of times before in relation to other things. So I'm hoping that we're going to be able to make those connections and look for those multiplication relations. The left-hand side is 1/4 of the right-hand side? Yes, the right-hand side is 1/4 of the left-hand side. Exactly right. That's why it's times 1/4. Great connection to make. We are ready for our cool down. When you mix 2 colors of paint in equivalent ratios, the resulting color is always the same. So complete the table as you answer these questions. The original ratio it gives us is 2 cups of blue paint and 10 cups of yellow paint. What color am I going to be making if I'm mixing blue and yellow paint? Go back to art class. What color would that be, Birdie? Nope, it's not going to be purple. What is it? Kate and S? It is green. Blue and yellow is going to make green. So this is the original amount, but if I don't want to use 2 cups and 10 cups, because that's a lot of paint to be making, what if I only wanted to use 1 cup of blue paint? How much yellow paint? And then the next one says make up a new pair of numbers. It can be any amount of paint that you want to use here. You are going to be working with your tables to answer questions 1, 2, including 3, and 4. What is the constant of proportionality? Work with your tables. Give you about 60 seconds. Online learners, pause the video to work through this cool down. We'll come back together and go over it in a second. How does the 2 change to become a 10? Good, Cambry. We multiply by 5. So what should I be doing here with this 1? Who have I not called on yet? Alexi. Multiply by 5. And 1 times 5, we don't even need our calculators for that. 1 times 5 is 5. It's not asking this question. What is this called when I see that 1 in the table? What is that called? Good, Addie. Gabe. Leah. Unit rate. What is it called when we see that 1 in the table? Unit rate. What is it called over here in this example when we see the 1 in the table? It's the unit rate. So when I see a 1 in the table, what is that called? Unit rate. So even though it didn't ask for it, let's add it in there. The unit rate is 5 cups of yellow paint per 1 cup of blue paint. Now, we could have picked any number of things here. I don't really care which one you picked. I'm going to make it challenging, and I want to know, what if I'm only going to use 1/4 of a cup? Because I don't have very much blue paint. So if I only use 1/4 of a cup of blue paint, how much yellow paint am I going to need? You guys are quickly typing it into your calculators. We'll wait. Hands are going up as they finish typing it into their calculators. Online learners, that's plenty of time for you to type it into your calculator as well. Timothy, double check, you're close. Allie, 1.25 or 5/4 of a cup. 1.25. Okay, that takes care of 1 and 2. It says how many cups of yellow paint should we mix? We answer that here, but let's put it here in our space as well. 5 cups of yellow paint. And for this one, I'm just going to point to the table up above. What is the proportional relationship represented by this table? For this question here, you can answer in a couple different ways, just like we answered it here on our summary. We can say the relationship between the amount of yellow paint and the amount of blue paint is proportional. The amount of yellow paint is proportional to the amount of blue paint. This table represents a proportional relationship between the amount of yellow paint and the amount of blue paint. So you can write this in a couple different ways. Here's the key thing that I want to get across. The blue paint is proportional to the yellow paint. And finally, this is where I really want to know who is paying attention all day. What is the constant of proportionality? What is the constant of proportionality? We might need to review on our summary page. The constant of proportionality is the number we multiply by to go across the table. So what is the number that I am multiplying by as I go across this table? Porter. It is 5. So the constant of proportionality is 5. What does it represent? Let's maybe give ourselves a reminder. It's the number we multiply by. As we go forward across the table. And I hope that you see this connection too. We see that we're going forward by multiplying by 5, but we also had the unit rate was 5 cups of yellow for 1 cup of blue. So make that connection here as well. That's the same as the unit rate. Ladies and gentlemen, your homework is the Lesson 2 Practice Problems, 7.2.2 Practice Problems. I want to explain what you're seeing here first. So eyes on the screen. This is a fill in the blank, but it's a fill in the blank using these terms. That's why it says bank of terms. You can use one of the blanks, tablespoons of chocolate syrup, and another blank 4, and another blank cups of milk, and another blank cup of milk, and another blank 3 halves. Some of them will be used multiple times. Okay, so use these terms to fill in these blanks. That's it. We'll see you next time.